Okay, where I would expect you to be and where we're going to explain some things today. Certainly I would expect you, can you read that? To be understanding multipliers, and I'm going to go through quickly and ask individuals what the multiplier of the following would be. So think back, what was multipliers talk about? So I'll give you an example. If we had a 27% increase, if we had a 27% increase in price, then the multiplier would look like that. So whole pie, 100, plus our 27 over 100. Okay, what this says is we're getting 100% of the original, whatever that is. What does that look like? That looks like 100 over 100, and 100 over 100 is 1.0. Added to that is another 27%. What does that look like as a fraction? It looks like that, which is plus 0.27, and 1 plus 0.27 is 1.27. So that's a quick catch up on the past. We've been through it in other lessons. It's on the YouTube site. When we are decreasing by 20%, decrease 20%, we no longer have the 100%. Okay? So it's again our 1.0 subtract our 20%. What does that look like? 20 over 100. 1.0 take 20 over 100 is 1.0 take 0.2. And so we're only getting 80 or 0.80 of that total for 20% off. Now this is the quirk that some of you are struggling with, that if we had a 20% discount, that the multiplier would look like 0.8 and not 20. Alright? What that's saying is, if that's our pie for 100%, don't pay 100%, take out 20. What does that leave you with? 80%. Okay? And if you feel relatively confident with that sort of calculation, relative, we'll see. Let's go to a new one, maybe. Yeah, perfect. All right. Caitlin, an increase of 10%. Luke Rothy, a increase of 8.2%. Tish, a decrease by 15%. What's the multiplier? And Brooke, a decrease of 8.2%. What's the multiplier? Okay, the rest of you be trying to work it out, because I might just go, in fact, don't do it, Caitlin. I'll get Ben to do it. But I'll stick with you at the moment, Caitlin. You've got a relatively common one that we've seen in the past. What would the multiplier be? If we're increasing by 10%, what would the multiplier look like? Yep, no worries. Are we getting 100%? Because we're increasing a value by 10%. Are we getting the original value? Okay. So it has to at least look like that, mustn't it? Must be at least 1.0 because we're increasing. Okay? We're increasing by 10%. What does that look like as a fraction? What does that look like as a decimal then? 0.10. And that's your multiplier. 1.10. Yeah, you just did it. Do you know what you just did? And Luke, increasing by 8.2%. Excellent. Again, a common error will be to look at that and go, oh yeah, that's a multiplier of 1.82%. What are you saying, Isaac, by putting a multiplier in like that?
It's 82% instead of 8.2.
You're saying that's an 82% increase instead of 8.2. It's a fair change. All right. Tish, I think I had for the next one, decrease by 15%.
0.85.
And how did you get 0.85? Talk me through your thinking and your process.
Emily told me.
Emily told you.
Well,
Don't
not
lie the
no.
way Emily does that.
No, because
No,
everything,
I was
all the
helping
ones,
her figure it out.
Yep.
all the ones I do these, I got all wrong, so I don't know. So.
Yeah, okay. So I need to slow down. Those that understand it can go on with their learning. Be honest with yourself. Be honest in your own stomach. Don't look at the person alongside you and go, oh, they're getting on with it, so I might as well too, even though I don't get this. The moment where you were away for this, Tish, weren't you?
Yeah, we were away. It was the last week I done it. It was still yeah, me and Steve were away.
But it is on YouTube. Alright? So pick it up from there. But, Tish, if we were to pay $5 for something, and there was no discount, no nothing, there's no discount, no increase, etc., and we still paid $5, how much of the original price did we pay? We paid 100%. Okay? If we were to increase that by 15%, so let's just go with increase, or do you get them pretty easily?
I got all wrong.
Yep. So if we're increasing something by 15%, let's say $5, okay? We're increasing $5 by 15%. Are we going to get the $5? Are we going to get 100% of it?
Yes.
We're going to at least get the $5 back, aren't we? All right? So that's what you should be thinking. I'm going to at least get, if this is a pie chart, I'm going to at least get my $5 back. Plus I'm getting another I don't like doing dots too quickly. Plus I'm going to get another 15%. Okay? You know through the very introductory stages of this, hopefully, and from year 7 and 8, that 15% as a fraction looks like that. Okay? Where we grab the 1, the 0, this is the way I try and get everybody to remember it, whether that does or not, and the 0 we get 15 over 100. And when we do that as a decimal, we get it to look like that. You alright with that? And so we're getting 100%, which is 100 over 100, which is 1.0, plus 15% because we are increasing. Does that make sense? Is that alright?
Yeah.
Let's look at decreasing. Alright?
Okay, I get it.
So we're going to decrease now. Alright? If we're decreasing $5, so, yeah, sorry, back here, so you're doing 1.15 multiplied by 5 would give you your new amount of dollars, yeah? Alright. Do you want to do that? So you're going to get $5.75 back. Alright. In this one, we're decreasing this time by 15%. Alright, and you go through the thought process and you say to yourself, am I going to get my $5 back? I'm decreasing $5 by 15%. I'm not going to. I'm going to get 15 off this time, so I'm going to get the rest of that. Yeah? This is sort of a picture in your mind that doesn't really add much, but it just at least says, I can't have anything in this column. I can't have a 1 here because I'm not getting 100%. That's where that originates from. So I'm decreasing by 15%. Okay. So if I've got 15%, that looks like 15 over 100, which looks like 0.15. And instead of getting my 100%, which was 100 over 100, I'm getting 0.15 less that one. 0.15 less the 100%. And when you do that, that gives you 0.85. And when you multiply that by $5, you get $4.25.
Yeah. I don't even know what I'm doing.
Is that okay?
Yeah.
Can you go back and just reschedule them, please? Okay, the following shows road crash deaths in Australia, states and territories. The number in May 2010 compared to May 2011. Calculate the percentage change in road deaths from May for each state and territory. Okay, so if you scroll back to the top, it's talking about using this formula here, being the multiply new amount divided by the original amount, okay? So if we go back to that question, so we're putting together all that we knew prior, all right? That's the important thing. All the skills that you learned prior to this are really important to this. And in the example, Tasha, I'm assuming you're paying attention because you said you're nearly up to it. Complex to all of that is this formula here. What we're starting to introduce to year 9, I suppose, are formulas that you've got to constantly work with. All right? So a cost price is the price that it costs you, obviously. Then the multiplier, this is why multipliers come in so handy. And then you have the selling price. So an electrical goods store buys a TV set at a wholesale price. The price of the TV is increased. The moment you see the word increase, Ben, what do you think in terms of the multiplier? The moment you see the word increase, what do you think in terms of the multiplier? What does it look like?
It has to be above 1.
Excellent. Perfect answer. It has to be above 1. It has to be 1 point something the moment you see increased. How much is it going to be increased by? It's going to be increased by 25%. What does that look like as a multiplier, Tony?
By 25%, 1.25.
It looks like 1.25, and I'd at least hope that the increased multipliers you'd be able to get now. Pretty easy. 1.25. Okay. Do I need to go through why we got 1.25 there for anyone? No? 1.25 is the multiplier. Its selling price is now $5.50. Its selling price is now $5.50. What price was it originally bought for? Okay? So this is using your Pythagoras' theorem, taking things over the equal sign so that you can leave the cost price on one side. Cost price times 1.25 equals 550. Okay? Then 550 divided by the 1.25 gives you 440. The original price was 440 there for that product. But all the time, folks, you're using this. You're using this formula there, which is very important. Are there any questions with that at this stage? So what did I do? I went through the examples that are given, and then I try and do the basic ones which build up to the more difficult ones. I try and work out from reading it carefully, are they giving me the cost price, the original price? Are they giving me the multiplier, etc.? Okay? Because eventually they'll be asking you for one or the other. They'll be asking you to find the cost price, the new price, or the multiplier all the time. All right? The moment you see the word increase, it's got to be 1.2. Decrease has to be 1 take 0.15. All right, Charlotte? Is that okay?